Welcome to today's lesson. This is SmartLearn Kenya Junior School STEM. So today we are going to discuss integrated science signal paper section B, which is full of structured questions. Remember, section A, multiple choice questions video is already out. If you've not checked, please check. Don't forget to like, subscribe, and tell a friend to tell a friend. So without further ado, we are going straight to the first question, which is question 31, and it says, grade 7 learners were learning about Bunsen burner flame. An image of the Bunsen burner flame provided with labeled region. So from that flame, the way it is steady and small, so automatically it's a non-luminous flame because it's small, has 4 regions, and at the same time is steady. So identify the hottest part. The hottest part of a non-luminous flame is the pale blue region, which is in that diagram is region 3. Region 3, that's the hottest part of the flame, and you get your 1 mark. Explain why the blue flame is preferred for heating. So we prefer blue flame for heating because number 1, it is non-sooty. It is non-sooty, which means it doesn't produce soot. Hence the apparatus does not get dirty. Number 2, it is extremely hot. So it being extremely hot means that burning of substances is easier and faster. So those are the 2 main reasons why we use the blue flame, which is non-luminous flame, for heating. Question 32, which is on reproduction. It says Sheila, a grade 8 learner, is studying a picture below of female reproductive system. So as you can see, that's a picture of a female reproductive system. Just before we go to the questions, maybe we can just name the parts. So part X is what we call the ovary. It is 1 when it is 2. We call them ovaries. The main function of the ovary is to produce ovum or an egg. The part that I'm labeling right now is oviduct, which some people call fallopian tube, or the other name is fallopian tube. It's where fertilization takes place. Then we have part W, which is the uterus, or womb. This is where implantation takes place. And remember, implantation is the attachment of the zygotes and the wall of the uterus. We have this part, that part called cervix. Then we have another part there which we call the vagina. Some people call it birth canal. It allows for deposition of sperms and at the same time allows for giving birth to take place. So let's go straight to the question. Name the part labeled W. The part labeled W is called uterus. The way I've just said initially, it's called the uterus. Then you're done. You get a mark for that. Identify the process that takes place in X. X is the ovary. So in ovary, we have the process that occurs in the ovary is what we call ovulation. And ovulation is the process by which the ovary releases an egg awaiting for fertilization. So we have 3 major processes here. We have ovulation, which takes place in the ovary, fertilization, which takes place in the oviduct, and last but not least, implantation, which takes place in the uterus. As simple as that. Question 33. Energy exists in different forms in nature and plays a crucial role in our daily lives. So Mary pushes a swing and it moves back and forth identify the main energy transformation that takes place in this motion. So this question is about energy transformation, which is grade 8 work. Energy transformation is the process by which energy is changed from one form to another. So a swing will always move back and forth, and in the process, the switch of energy switched from kinetic to potential, from potential to kinetic, then potential. So if this is a pendulum, it will move back and forth. So in the middle here we have what we call the kinetic energy at the maximum, and at both ends we have what we call the potential energy, which I can label them like as P on in the other at the maximum. So it will be moving back and forth, achieving potential, kinetic, then potential. So the energy transformation here is potential energy, because it's moving back and forth, is potential energy, then an arrow, kinetic energy, then last but not least, potential energy again. That's the energy transformation. So just to be clear, when writing the energy transformation, make sure you use arrows to show how energy is changing from one form to another, and this is in line with the principle of conservation of energy, which says that energy is neither created nor destroyed, but is changed from one form to another. So part B, a battery is used to power a flashlight. Identify the energy changes that occurs from the battery to the production of light. So a battery contains what we call chemical energy. Chemical energy is also contained in fuels and in food. So chemical energy, which is the first energy that we will start with, chemical energy, then an arrow. So when the battery produces the chemical energy, is transferred through wires towards the bulb in what we call electrical energy. Then last but not least, because it's a flashlight, it will produce what we call light, and of course heat, light and heat, because after some time the flashlight, the bulb will always heat when it goes on for a long period of time. So that's the energy transformation, which is same as energy changes. Identify the energy changes. Yes, like that. So the next question, name form of energy stored in food and explain how the body uses it. I've just said food will always contain a form of energy called chemical energy. Chemical energy is always stored in food, fuel, and battery. So explain how the body uses it. So body converts chemical energy to other forms of energy, to other forms of energy that helps our body in various activities. Our bodies in various activities. Yes. So explain how the body uses the energy. The body converts the chemical energy to other forms of energy that helps our bodies in various activities like talking, sleeping, eating. All that comes from chemical energy from food. Thank you for that. The next question. James is studying atomic structure in a class. He observes a model of an atom shown below. So this is a model of an atom. It has the nucleus which contains protons, the nucleus which contains protons and neutrons. Of course, under the energy levels, or we call the orbits, this is what we call energy levels, or some people can just call them orbits. Then it has what we call electrons. So because it's one, I'll just write electron because it's one, but when there are many, you write electrons. So these are parts of the nucleus. So describe the structure of an atom. So an atom contains the nucleus, which an atom has nucleus which contain protons and neutrons, and is surrounded by energy levels containing electrons. That's how you describe the structure of an atom. This is a general question. I differentiate between atomic number and mass number. So atomic number is the number of protons in an atom, while mass number is the sum of protons and neutrons in an atom. So atomic number is the number of protons in an atom. While mass number is the sum of protons and neutrons in an atom. Sum of protons and neutrons in an atom. So when a question says differentiates, make sure you separate the two sentiments or the two statements with the word while, whereas, or sometimes you can use a table to show the difference between the two so that you can get your full mark. The next question, Linda is researching elements and their property. She comes across magnesium. She comes across an element called magnesium. Describe the electron configuration of element with atomic number 12. Remember, magnesium is atomic number 12. Its energy configuration, we start with the first energy level, which contains a maximum of 2. So then you put a comma. From 10 it remains 8. Then you put 2, a comma. Then you remain with 2. So that when you add the 2 plus 8 plus 2, you get 12, which is the atomic number. Remember, the atomic number is same as the number of protons and is same as the number of electrons. And that's why we say an electron is electrically neutral. Explain how electron arrangement determines an element's chemical property. So electron arrangements determines bonding and coordination of an element. So I'll repeat the question. Explain how electron arrangement determines an chemical element's chemical properties. So it determines bonding and stability of different elements, instability of different elements, then you get your marks. So question 35, we have a diagram there. It says metals and non-metals have different physical properties that determine their uses in various industries illustrated. Here in picture A metal is being heat to produce a sheet, a property we call malleability. And here a metal has been drawn into thin wires, a property we call ductility. So malleability is the process by which a metal is hammered into thin wires, the way it's shown there, and malleability. And then ductility is the process by which a metal is drawn into thin wires. So identify the physical properties of the metal shown in the picture below. So the properties of A is what we call malleability. And the properties of B is what we call ductility. Drawing wires from metals is what we call ductility, and malleability is the process by which metals are hammered into thin sheets. Explain how metals and non-metals differ in terms of physical properties. So generally metals are hard, resistant to corrosive, and strong as compared to non-metals. So generally metals are hard, resistant to corrosion, and strong as compared to non-metals. As compared to non-metals. General metals are hard, resistant to corrosion, and strong as compared to non-metals. Yes. Give one examples of non-metals and their uses. Two examples of non-metals and their uses. There are a lot of non-metals. We can have oxygen as a non-metal. Which is used by patients with breathing difficulties. Then another metal, we can have carbon. Which is used in making pencil leads. I'm sorry for lack of space there, but hopefully you've understood. Question 36. Peter, a grade 8 learner, drew the cell shown below. She observed under a microscope. So the way you see that cell, it's a plant cell. Because it has a regular shape. That's the main reason. And the nucleus is at the periphery. Which organism does it belong to? It belongs to plants. What is the function of the part labeled F? I believe the part labeled F is the nucleus, and the main function of the nucleus is to controls all the activities of the cell. So we have part A, which is the cell wall, part B, which is the cell membrane, part C, which is the cytoplasm, part D, which is the chloroplast, part G, which I believe is the mitochondrion, then part E, which is the vacuole. So those are what the answers that you're supposed to put there. So question 37, the diagram below represents a lower jaw of a mammal. This is grade 9 work. As you can see, we have a toothless gap here. We call diastema. A toothless gap, we call it a diastema. Anytime you see the toothless gap there, automatically you know that the mode of nutrition is Holozoic, but under what we call herbivorous or herbivorous. J is the incisors and L is the molars. So name the mode of nutrition whose the jaw shown. So the jaw shown is of a herbivore. So the mode of nutrition is herbivorous, which is under the Holozoic mode of nutrition, where animals depend on complex materials for digestion. So it is herbivorous, and the main reason, if they ask you, give a reason for your answer, because it contains what we call a toothless gap called the diastema. Name the toothless gap K. As I've just said, it's called the diastema. The toothless gap is called the diastema. But instead, the function of the gap. So the function of the diastema is it allows for manipulation. It allows for manipulation of vegetative materials. You can say vegetative or plant materials, it depends, but it allows for manipulation of vegetative materials in such a way that the plant materials that are getting inside the mouth do not mix with the ones that are already in the mouth. So the next question stated the substance that responsible for hardening of teeth. Hardening of teeth is calcium sulfate. Calcium sulfate is a substance that is responsible for the hardening of teeth. Question 38. Metals are widely used in construction and industries, but some face challenges such as rusting. Alloys are often used to improve metal qualities. What is rusting? So rusting is the formation of a red brown coating on the surface of iron or steel. Rusting occurs only in iron or steel. All other metals undergo corrosion, not rusting. So when they tell you what is rusting, you say it's the formation of a red-brown coating on the surface of iron or steel, and rust is hydrated iron 3 oxide. So a construction engineer needs a strong, resistant material for building bridges. He chose an alloy. Explain why alloys are preferred over pure metals in construction. You have the answer already in the question, because they are strong and rust resistant. because they are strong, durable, and rust resistant. That's why alloys are preferred over pure metals. Acids and bases have distinct physical properties and important application in daily life. Describe the physical properties of one physical properties of an acid and one physical property of a base. So acid, they are sour in taste. When you taste acids are sour. Example, we have sour milk, we have lemon juice, which are sour in taste. Base, they are bitter in taste. Bitter in taste. There are other properties of acids and bases. Acids are also sticky when you feel with your fingers, while bases are soapy or slippery when you feel with your fingers. Those are also other properties of acid and bases. Acids turn red blue litmus paper, turns blue litmus paper red, and bases turn red litmus paper blue. Give one real life application of an acid. There are many applications of acid. We can say hydrochloric acid, HCl, is used in digestion. Digestion as one of the application of acids in real life. But acids, we have nitric acid, which is used in making of paint. Acids are used in making of fertilizers. We have carbonic acid, which is used as a preservative in soft drinks, among many more others. So bases, we can say lime is used. Lime is used to reduce acidity in the soil. It's used to reduce acidity in soil. This one is supposed to be acidity. The spelling is a little bit wrong. Lime is used to reduce acidity in the soil. We have also anti-acid tablets are also used to neutralize acidity in the stomach, among many more others. Indicators are used to determine whether substances are acids or bases. Whether substances are acids or bases. There are many more uses or real life application of acid, bases, and indicator that you're supposed to know. Question 14 says, below is a diagram showing two beakers. One contains hard water and the other contains soft water. When the same amount of soap is added and shaken, one produces more leather than the other. So this one is soft, it contains soft water, and this one contains hard water. Hard water leathers easily. Hard water does not leather easily, That's why it produces less foam as compared to soft water. So based on the diagram, what is meant by water hardness? Water hardness is the ability of water to contain dissolved dissolved, to contain dissolved salts or minerals. And when it comes to salts and minerals here, we are talking specifically about calcium. And magnesium, calcium and magnesium ions. Suggest two methods that can be used to soften temporary hard water. So the first method for softening water temporary is boiling. Temporary, we use mostly boiling, but we have others like adding chemical method, which is adding washing soda. You can also use distillation as a method of softening temporary hard water. So all these three methods can be used to soften temporary hard water. But when it comes to permanent hard water, boiling is excluded because it doesn't restore or it doesn't soften permanent hard water. Alloys, question 41, are used in various industries due to their improved properties compared to pure metals. Define an alloy and give two examples. So an alloy is a uniform. An alloy is a uniform combination. It's a uniform combination of two or more metals, and sometimes non-metals, two or more metals, and sometimes a non-metal to improve the chemical property of a substance. So it's a uniform combination of two or more metals, or sometimes non-metals to improve the properties. Examples of alloys. We have the first one. We have what we call stainless steel. Another one we have is brass. We have duralumin. We have bronze, among many more others. So part B, the table below shows a composition of different alloys. Study it and answer the question that follow. So the table, one side is written alloy and the other side main components. So steel is made up of iron and carbon, brass is made up of copper and zinc, and duralumin is made up of aluminium, copper, magnesium, and manganese. Why do you think duralumin is preferred over pure aluminium in aircraft manufacturing? Because it's light and durable. Durable, it can stay for a long period of time. Aluminium is light, but duralumin is lighter than aluminium. That's why it's preferred in making of aircraft parts. The next question 42, which is the second last question. Pressure plays an important role in various daily applications involving solids and liquids. Mr. Karimi wore a high-heeled shoes to school. Explain why high heels should exert more pressure on the ground than flat shoes. Because they have smaller surface area. They have smaller surface area. because they have smaller surface area. I've just abbreviated it because they have smaller surface area. The smaller the surface area, the higher the pressure. The higher the surface area, the smaller the pressure. Part B, a nurse uses a syringe to give an injection to a patient as shown in the diagram below. As you can see, this is the syringe. And then this is the hand. So when the plunger is pushed, the liquid medicine flows out through the needle. Explain how pressure is applied in this process. So from Pascal's principle, we say that pressure applied at one point of a liquid, enclosed liquid, is equally transmitted to other parts of the liquid. So here, pressure applied on the plunger is equally transmitted, making the liquid medicine to come out, making medicine to come out or to flow out from Pascal's principle. Identify the principle of pressure used in car braking system and explain how it helps to stop moving. So in car braking system, the principle applied is what we call the Pascal's principle. The same principle that I've been talking about on the previous question. Pascal's principle says that pressure applied at one point of the liquid is equal transmitted to other parts of the liquid, provided the liquid is enclosed. So explain how it helps to stop moving. So pressure applied on brake pedal, on the brake pedal is equally transmitted to the tires, causing stoppage. So that marks the end of our paper. Please like, subscribe, and share, and tell a friend to tell a friend. Thank you very much for tuning in.